Okay, now we're going to do center of mass again, but this time we're going to do the center of mass of a continuous object. And we have this object like a triangle here. And we want to know how to calculate the center of mass of the object using the integration format of the center of mass. And then we'll actually check it by experimentally finding the center of mass and seeing if our answer is close. So we're going to do integral x dm over dm. I already measured the dimensions. From down here to here is 54 centimeter. From here to here is 22 and a half. From here to here is 22 and a half. So this is a regular equation, y equals x equation. So how do we calculate the center of mass of this? Well, we're going to break it down into little rectangles here. And the equation here is going to be y equals x. And we're going to integrate from here to here. Then from here to here, we have to integrate another function. What's the equation of this function? So if you think of this as a certain line, what would be the equation of that line? Well, we know over here is 54, 0, and we know here is 22.5, 22.5. So that's we know 2 points on it. So we know y minus 0 is equal to 0 minus 22.5 over 54 minus 22.5 times x minus 54. So we're going to have to get the equation. How would you integrate that now? So what you would do is you go x center of mass is equal to integral. That area is going to be x dm over integral dm. So you always start that way. Then you say x dm is going to be sigma dA over integral sigma dA. Sigma is the mass density of the material. But the sigma cancels. If it's a uniform material, then it really doesn't matter what it's made of. Could be metal, wood, or anything. It's gonna cancel out. So the x center of mass is gonna equal integral x dA is gonna equal y dx over integral y dx. Now I'm gonna have split this into two integrals. So I'm gonna have x, y is for this equation is gonna be just x dx from 0 to 22 and a half over integral x dx from 0 to 22.5. So this bottom integral is missing one of the x's. It only has y dx. It doesn't have an x here. Then I'm going to add to this equation, integral 22.5 to 54 from here to here. And then you're going to have x. And then you're going to have y, which you're going to put this equation, plus 38.57, 0.571 dx. Then I'm going to divide this by 22.5 to 54. And then I'm going to divide by the same thing, except it's not going to have the x. Okay? This one is pretty quick because you just have x squared. So the integral of x squared is x cubed over 3. So let's go over here now on the side. 0 to 22.5. This one, I can just do it on my TI. So just put that integral in and this time it's much smaller, 354.344. So now add this to this number, 11693.163 added to 22 and a half cubed over 3. The 0 just gives you a 0. So added to 22.5 to the power 3 divided by 3. 15,490.038 over, and then here 354.344 added to 22.5 squared divided by 2, 607.469. Then you go divide them, 15,490.038, and you get 25.5 centimeters. So according to this, the center of mass should be a little bit to the right of this, the x component of the center of mass, somewhere about here, not completely halfway, because 25 is not even half of this, so it should be somewhere around here. And then you could do something similar for the y component, and then find the y component of the center of mass. Now let's do the experimental way. Here is what you do. You take this, and you basically drill random holes, and all you need is like 3 holes. Here we have drilled different holes, and then I have a string, and I can hang it from any of the holes. Okay, so let's say I hang it from here. Okay, so you let gravity do the rest of the job here. You just take this and try your best here to draw a straight line. Okay, and actually the whole locations is the line that we're gonna get. You know what, let me get the other ruler. Okay, so you can see there's a line here that I got. And then I'm going to hang it from another location. Okay, then I'm going to hang it from an arbitrary third location. As long as you have 3 locations, it should work. And so now you're going to go like that. You could also do 4 lines, 5 lines, 6 lines. They should all go through the same point. So right now, we found out that the center of mass is right there. Okay? So let's determine now if my calculation was on. So it was a little bit to the right of the, remember this one from here to here was 22.5. This one is a little bit to the right of that. So if you see here, I'm going to now go from this point down. So this is the center of mass. And then I'm going to measure the distance between here and here. Okay, 25 point, yeah, it's roughly about 25. So 25 centimeters. This is the experimental center of mass, 25. What did we get? Well, if you go over here, you see we got 25.5. So it was pretty good. Our answer was a little bit more. Now the reason the experimental answer is a little bit less, you can see here on the right side, a little chunk of the wood is missing. Okay? So what is that going to do? That's going to cause the experimental center of mass to be more to the left, this side. So it's going to cause this number to be a little bit less than our number. So it does come out and it makes sense. So you can see here how to do center of mass of an object that is continuous, how to do it experimentally, and how to do the calculations. Thank you.